Hello everybody, getting ready to do lesson 4.4 part 2 of pre-calculus math today. Here is my email if you need course materials, note-taking guides, worksheets, class worksheets, homework sheets. Today part 2 of 4.4, trigonometric functions of any angle. You have 2 points here for your notebook taking today, and then we have 36 points here of classwork to do. Teachers, here's today's bell work. Round your answer to 3 decimal places here. Solve the equation. Students, this is what you have to do today. Solve these equations for x. Teachers, give your students about 4 minutes. Okay, welcome back for today's bell work, students. Hopefully you're finished. So for the first one here, 27 would equal x minus 1 times quantity x plus 2. And how do we get that? Well, we cross multiply here, and then we get this here, and then we have a quadratic here because we move this over here. So x minus 1, x plus 2 equals 27 becomes x squared plus x minus 29. Now, this is probably the easiest way, is to use the quadratic formula here. Negative 1 plus or minus square root 117 over 2, and then you get these two numbers here. Or you could graph it and get that same thing. And then down here again, cross multiply, students. So you get 10x equals x squared plus 4x. And let's see, you move over your 10x over here, and you end up with x squared minus 6x equals 0. You factor it down, so x times x minus 6, x equals 6 and x equals 0, which you found out was extraneous. So x equals 6 would be your solution for this situation here. And another way, the best way to do it is just graph this and find out where your zeros are from that form. Okay, moving into our part 2 here, trigonometric functions of real numbers. To see how a reference angle was used to evaluate a trigonometric function, consider the point xy here. R equals your hypotenuse, and then you have theta, and then theta prime is your reference angle here. And then for theta prime, this is your opposite, this is your adjacent here. So to see how a reference angle is used to evaluate a trigonometric function, consider the point xy. So on the terminal side of theta, this will be over here on terminal side here. By definition, you know that sine theta equals y over r. So sine theta here, sine theta would equal y over r. And tan theta would equal y over x. So we already know that. And by knowing that, for the right triangle, again, the same situation here. For the right triangle with the acute angle theta prime, which is this angle over here for this triangle, the sides of lengths x and y, so x here and then y, are absolute values. I mean, they are distances here. So they are absolute values. They're not negative distances. So this will be a positive or an absolute value here for adjacent. So sine theta prime equals op over hyp, which equals your opposite side here over r, which is your hypotenuse. So it'll be the absolute value of y here. And tan theta prime would equal opposite over your adjacent, which is this value here. And even though it's a negative value here of x, the distance here is not negative. It has an absolute value. And the same thing here for your y coordinate up here. This leg here would be an absolute value of y over x. So it follows that sine theta and sine theta prime are equal, except possibly in sine. The same is true for tan theta and tan theta prime, and for the other 4 trigonometric functions. In all cases, the sign of the function value can be determined by the quadrant in which theta lies, and really where you need to know your different quadrants. So evaluating trigonometric functions of any angle. To find the value of a trigonometric function of any angle theta, 1. Determine the function value of the associated reference angle theta prime. So determine the function value of theta prime. 2. Depending on the quadrant in which theta lies, affix the appropriate sign to the function value. It helps to know the values of different quadrants for different functions. By using reference angles and the special angles discussed in the previous section, you can greatly extend the scope of exact trigonometric values. For instance, knowing the function values of 30 degrees means that you know the function values of all angles for which 30 degrees is a reference angle. For convenience, the following table shows the exact values of the trigonometric functions of special angles and quadrant angles. So for here, for 30 degrees, pi over 6, and is 1/2 in sine. Cosine is square root of 3 over 2, and then square root of 3 over 3 for tan for 30 degrees here. 45, 60, 45 is pi over 4, 60 is pi over 3, 90 is pi over 2, 180 is pi, and then 3 pi over 2 is 270. You should know that. And then 2 pi will be 360, right? And then these are your function values here for sine, cosine, and tan. So this table here is really important. And during classwork, I will have you copy all these values down in your table. It's important that you know these values. So getting into another example here. Example 5, trigonometric functions of non-acute angles. Evaluate each trig function. So cosine 4 pi over 3, because theta 4 pi over 3 lies in quadrant 3, the reference angle is theta prime. So in this situation here, here's your reference angle here. Here's 4 pi over 3 over here. So your reference angle is pi, which is 180. So theta prime would equal pi 3. So your reference angle, you go back here to your reference angle and be 30 degrees for 4 pi over 3 minus pi would equal pi over 3. Moreover, the cosine in this situation is negative. Cosine is adjacent, or rather it's x over r in this case here. So it will be your x value, which in this situation is negative. So it'll be cosine 4 pi over 3 would equal the negative of cosine pi over 3, which equals negative 1 over 2 in this situation here. Be negative 1/2. And then tan of negative 2tan. So because negative 2tan plus 360 equals 150, so negative 2tan plus 360. So negative 210, we are going this way now. Negative 210 would be 180 plus 30 would be right here. So your theta prime would be 30 degrees because you're 30 degrees beyond your reference angle here at pi. So negative 210 plus 360 would be 150. So this would be positive. This would be positive 150 here. It follows that negative 210 is coterminal with the second quadrant angle 150. So it would be coterminal with 150 here. But negative 210 is, for your reference angle, would be, using your reference angle here at pi, would be 30 degrees. Therefore, the reference angle is theta prime would equal 180 minus 150 equals 30. And then tan of negative 210 would equal the negative of tan 30, which would equal the negative of square root of 3 over 3. So the negative square root of 3 over 3 would be your function value there. And then cosecant 11 pi over 4. because 11 pi over 4 minus 2 pi equals 3 pi over 4. So negative, no, this is 11 pi over 4, so you go 8 pi, and then you go 3/4 more pi, which would be here. So 3/4 over pi, let's see. The second quadrant angle will be 3 pi over 4. Therefore, the reference angle is, right here, pi over 4. It'd be pi over 4. Theta prime would be pi over 4. Because the cosecant is positive, cosecant is 1 over sine. So here, your values will be positive for that. In quadrant 2, you have cosecant 11 pi over 4 equals positive cosecant pi over 4, which equals 1 over sine pi over 4, which equals square root of 2. I mean, it's a 45-degree reference angle here. Theta prime would be 45 degrees. Okay, let's try one. Evaluate sine, cosine, and tangent of the angle without using a calculator. So up here we got negative 17 pi over 6, and then down here we have negative 20 pi over 3. So theta equals 17 pi over 6, which is coterminal with 7 pi over 6, quadrant 3. It's a quadrant 3 angle. So see, so 7 pi over 6, I mean, it would be 2, and then, see here, 5 pi, correct? So it'd be 2 pi, and then you still have 5 over 6 pi. So 5 over 6 pi would be over into quadrant 3. It'd be down below 180. So theta prime would equal 7 pi over 6 minus pi would equal pi over 6. So it would be 30 degrees would be 210 degrees is what it'd be. But it'd be a negative, so it would move in a negative manner here. So these would be your function values here for negative 17 pi over 6 would equal negative sine of pi over 6, and then negative cosine pi over 6, and then tan pi over 6, and that would be your solutions for negative 17 pi over 6. And then negative 20 pi, again, we're moving in this manner here. It'd be 6 and 2/3 pi. So negative 20 pi over 3 is coterminal with 4 pi over 3 in quadrant 3. So theta prime would equal 4 pi over 3 minus pi would equal pi over 3. So now we're dealing with a 30, 60, 90 triangle, and then pi over 3 would be a 60-degree angle. So your other functions here for this would be negative square root of 3 over 2, and then negative cosine of pi over 3 would be negative 1/2, and then tan pi over 3 would just be square root of 3 for that. Let's try another example here. Using trigonometric identities, let theta be an angle in quadrant 2 such that sine theta equals 1/3, so we're over in here in this quadrant here. Find cosine theta by using trigonometric identities. So using the Pythagorean, we're going to use Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. And we know sine theta equals 1/3, so we just square 1/3 and then we solve here. Cosine squared theta equals 1 minus 1/9. Cosine squared theta equals 8/9. Because cosine is less than 0 in quadrant 2, you can use the negative root to obtain this. So cosine theta equals the negative, the square root of 8 over square root of 9 would equal the negative of 2 times square root of 2 over 3 would be your value here for that function. Let's try one again here and find the indicated trigonometric value in the specified quadrant. So sine theta equals the negative of 3 over 5. So in quadrant 4, sine of negative 3 over 5, then a cosine theta the trigonometric value for that, for cosine theta. And then down here, students, this is yours, cotan theta equals -3 in quadrant 2, and then the trigonometric value of sine theta for this function here. So to do this, we're going to use the Pythagorean again. So for that, we plug in here for a negative sine squared theta. We plug in our -3/5 and square it. And then what we come up with here is cosine squared theta equals 1 minus 9/25. And we get cosine squared theta equals 16/25. Then the cosine theta is greater than 0 in quadrant 4. So it would remain 4/5 for cosine theta for that one. And then cotan down here, we're going to use the Pythagorean here, identity. 1 plus cotan squared theta equals cosecant squared theta. We're going to plug in here for cotan, and then we're going to solve. So tan equals cosine squared theta. Cosecant, did I say cosine? Is cosecant squared theta. Cosecant theta is greater than 0 in quadrant 2. We're looking for quadrant 2. So taking the square root of both sides, we have square root of 10 equals cosecant theta. Then cosecant theta equals 1 over sine theta. So sine theta would equal 1 over cosecant theta would equal 1 over the square root of 10. You rationalize your denominator, and you have square root of 10 over 10.